All right. So hello, and this is going to be the first of a series of videos covering the summative review. All right, and so what I want to do in this first video is I want to talk really quickly just kind of about the different skills that we need to know in order to be successful on this, on completing this review, and then for the purpose of the review, being successful on the upcoming assessment that's going to look in many ways a lot like this review, right? It's going to have the same kinds of problems and all of that. So the skills that we are mainly talking about here that we have to have some traction on is we have to be good and understand, be pretty solid with factoring, okay? And then we also need to understand that we will be using our square root property, right? So we'll be using square root property, okay? We'll be using zero property, and finally, using both of these things, kind of, this ties into a very powerful solution tool called completing the square, all right? Completing the square. Let's talk just really quick about factoring. So with factoring, we got kind of like the two main methods that we're looking at for factoring, right? Is we have our GCF method, which is where you pull a factor, right, a greatest common factor out of all the terms, right, in your polynomial, right? So that would be a case where there's no grouping or anything. And then the other one is going to be grouping, and there's general grouping, and then there's like the AC factoring method. And pretty much we're going to concentrate on the AC method, right? And so we're going to go AC method, okay? And we'll talk about all of these in the upcoming videos, right? But it's just really important that we, look over, our previous lessons, and that we've got a handle on these, because that's these are skills that we're going to use all of this stuff moving forward, when you're solving anything, right? Whenever you have any kind of algebraic equation, you are likely going to use at least some of this, of what you see on this page right here, right? So it's just really good to kind of get that, right? So let's take the remainder of the video and let's just look over kind of the greatest common factor factoring. All right, so that applies to this problem right here. Okay, so when we talk about factoring something completely, right, you can use GCF, right? You can use GCF when, all right, you have common factors, all right, in all the terms, right? When in all of the terms you have common factors in all the terms, or a common factor is fine, right? So in this one, you look at this, hopefully you recognize that, well, hey, first of all, both of these are divisible by 6, right? Both of these are divisible by 6. So I know that I can pull a 6 out of both of these. I also see that both of these has at least one A in it, all right? And so when you're trying to determine how many you got to pull out, you can pull out only, you look at all of them, and the least amount that you encounter in one of the terms is the one you use, because you can't pull out more than what's there. So I can only pull 1 out of this one. Even though I can pull 3 out of this one, I can only get 1 out of this one, so that's the most I can pull out. Okay, and the same thing with the B's. I have 2 in this one, I have 4 in this one, so you take the least, even though it's called greatest common factor, that's kind of how it works. You got B, you're going to pull out 2, all right? Because I can't pull more B's out of this one, right? It's not there. It's not there to take out. So at that point, then what we're going to do is we're going to basically reverse distributive property this, right? We're going to reverse distributive property. There is a whole video on this. This is like the first video on the unit, right? is talking about this method. So if you need more practice on this, go back to that and look at that. But 6ab squared, so the way, I think the easiest way to think about this is what do I have to do to go from this term to this term, first of all right? And so you just think about what's missing from this one that's in this one. Well, this is 6, it needs to be 24. What do you have to multiply, because we are using distributive property to get 24? Well, you have to multiply 4, right? 6 times 4 gives you 24, okay? The next thing is you look at your A's, right? My A's, I've got 1 here, I've got 3 here. So I need to get to 3 from 1. So 3 minus 1 is 2. So I need 2 A's. And that's how you approach it. If you only needed 1, you would just write it down and put no exponent. All right, now for b squared to b squared, it's already there. So you can think of it as like times 1. But if you already have some stuff in the same monomial, then you don't have to include that, right? So I'm not going to include that in this one. But there are times where you do need the 1. All right, and so this term is now complete. This is satisfied. We've got it from this. And then your sign is usually going to be the same sign that's here unless you factor something out that's a different sign from your leading coefficient, right? So we're going to go minus. So to get from 6 to negative 18, I need a negative 3. So that's where the minus comes from, right? My A is already taken care of. There's 1 here, there's 1 there. I don't need to write another one. And because there's already a factor here, I don't need to write times 1. Okay, and then b squared, I want to go from that to b to the 4th. So I need 2 more b's. And then you are complete. So this is how the greatest common factor method works, right? You should be able to do this with as many variables as popped in front of you. The big thing is whatever you pull out that goes outside the parentheses has to be something that is represented in all of the terms. And if it's not represented in all the terms, then that's the stuff you leave inside the parentheses. So it's like, okay, I'm pulling stuff out here, 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 right? And then that's where you're at. Okay, so that's how the greatest common factor method works when it's present in all the terms. In the next video, we're going to look at factoring by grouping and primarily using the AC method.